Hello everybody, I'm Paul Meenan and welcome to this, my very first YouTube video on this, the E5 channel. Now before we get started with this video on demand, there's a few pieces of information you need to be aware of when watching it. Firstly, this video is based in the United Kingdom. It's relevant to electricians, engineers, managers of electricians, students, designers and specifiers of electrotechnical systems here in the UK. If you're watching this as a DIYer, this is not the video for you. This is not for the home novice to be watching and playing around with things, okay? So please don't muck around with electricity or fixed electrics in any way, shape or form. Always get a qualified and competent electrician. So with that in mind, you look at the picture and you think, this is a video about sockets. Well, it is. It kind of isn't. It's about partly sockets. So if you can see the picture above me is something that many an electrical inspector will walk into a house, the owner of the home will unplug all the stuff that they've had plugged in since Christmas, and immediately they'll find a burnt out socket, which shouldn't be a problem, it's replaceable. But what causes it? Well, it's these things, overloads. We seem to be as a society consuming more and more electronic products which need more and more charging facilities. But fixed wiring in some houses in the UK has never changed. We've had socket outlets installed in houses, in skirting, in architraves, all sorts of places that have been there for 40, 50, 60 plus years. This wiring is old, and as every year goes by and the loading increases, obviously the strain on the conductors increases. So you eventually get burnouts, you get products failing, but more importantly it's a fire hazard. It's a safety risk to the homeowner, ones which they're blissfully unaware of because there's no real statutory law for a homeowner to go out and have their wiring checked. It's more about the homeowner realising that it's like an MOT. You should always have your electrics checked. So I highly recommend, if anybody is watching this who isn't electrically qualified, make sure you get your electrics checked by a professionally qualified and competent person. So this video is talking about sockets and the overloads, but it's talking about something new that's come out in recent years. And the thing that's come out new in recent years is these devices here. As you can see from my arrow, it's the USB socket outlet. Now USB means universal serial bus, and for the last few weeks I've been playing with these devices here just to experiment with them and do various bits and bobs. However, this video is not me pulling them apart and filming it. If you want to watch videos, there are people far more qualified and competent than me who are world class at experimenting on electrical equipment and proving their safety, so check their YouTube channels out. I'll put some links somewhere. This video is about sockets, USB outlets, more specifically the USB part itself. So let's get cracking straight on. Hopefully you'll get some really interesting nuggets from this video. So let's start where you should start with any conversation around electrical systems, and that is standards. As you can see, we have a very clear picture of a modern BS1363 type 2 socket outlet. You go into Wix and you buy these. They're available and they're reasonably simple to change. However, again, would recommend a qualified and competent electrician is able to do it, because then he can ensure that the circuit is safe for the additional load and there isn't any horrors lurking behind. So within every standard, I'm going to ask you a question, and the question has just appeared, and it's a very simple question. Should we be verifying them? Now, lots of people watching this will go, yes, of course we verify them. We plug into the socket and we verify it when we're doing our earth loop impedance testing. I'm not asking the question of should we be verifying the socket function, which you'll be doing when you're doing your inspection and testing anyway, because you'll be proving the functionality of the switch and you'll be measuring earth loop impedance. What I'm asking you is, should we be verifying the USB output? And there is a logic and there is a reason why, and it's probably a question you've never been asked before. So should we be verifying, and why am I asking the question? Well, that's very simple. So within BS1363, which you can see on the far right, there is this Annex I, which deals with USBs within sockets. Section 3.5 says conformity, and it says conformity to I 3.1 to 3.4 shall be checked by inspection of conformity, evidence or by test. So when you buy your socket from the wholesalers and you get that little square document, does that fill you with joy that it's fully compliant with the huge volume of standards that exist currently, or do you get data sheets from the manufacturers? Well, the answer very simply is, well, in my professional opinion, no. We get a little sheet that tells us how to install it, a few little badges and rubber stamps and declarations, but that's it. There should be evidence behind that. And the manufacturers don't have to provide that with every socket they sell, but the manufacturers should be able to provide evidence that they are conforming. So how many people have gone to their wholesaler or rung up MK or BG and asked them for proof of the certification for the USB component? Worthwhile doing. But then we come on to the main thing that most electricians always use, and that is this document behind me, and it's the latest edition of the IET wiring regulations, which we're currently sat at the 18th edition, which came out in January. We're now sat in February. So it's just come out, and immediately you're thinking, oh, hang on, Paul, is there a requirement for USB charging in this? Is there anything about USBs? Well, no, absolutely not. There's nothing. It doesn't mention USB once. And yet this technology we've been using now in Hager for 5 or 6 years. But that's okay, because that standard over there covers everything we need to know. However, given the fact that both standards have just been published in the same year, so you can see 2018 above me, and then obviously 2018 there, I would expect them to be very harmonized. And of course, reading them, they may not be as harmonized as we would so like. So let's get into it a little bit more, because there's a statement in the wiring regulations behind me in section 64373.201, and it makes a statement that got me really thinking, and it says the prospective short circuit current and prospective earth fault current should be measured. Well, yeah, electricians do that anyway. Calculated or determined by another method at the origin and at other relevant points in the installation. And it was the other relevant points in the installation that really got me thinking, why can't I do that at the USB? Should I be verifying any short circuit, or should I be proving at least that short circuit? Should I be looking at the voltage output, the power output, and looking to see whether it protects itself? Because in that standard there's lots of criteria, henceforth section 3.1, 3.4. It doesn't really do much at the moment, to be honest with you. So before we get into the depth of it, I just want to show you what USB sockets are, and let's take a look at them. So very simply, you can see here you've got the more expensive range of USB socket outlet, where it's 2.4 amp per unit per USB. You've got an LED indicator that tells you obviously when it's charging and when it's finished charging, which is a really smart, expensive socket. It's screwless, so it's a decorative type plate. You've got the more basic one you can get in Wix and B&Q. You've obviously got the really smart screwless brushed chrome, and this one's even got a type C USB charger, which is going to become a new standard, but we'll get onto that in a second. And then you've got the single gang, run a twin and earth, supply to the back, plug in 4 smart devices. There is a huge thirst for charging of smart devices in the UK. Absolutely huge. In fact, you can even get socket outlets now where you've got 4 of these on the twins. It's absolutely incredible what they're fitting into these sockets. So USB sockets, as you can see here, some of them have shutters, which, as you can see, is great. Absolutely fantastic. Now, why is that important? Well, I actually think these are the best designs of USB socket outlets, and the reason is fairly simple. One, I can't insert a pen into the USB component, henceforth damaging it. More importantly, if I have a socket that sits somewhere, even if it's at a 45-degree angle, I don't get any dust accumulation. I don't get dust into the back that can cause it to prematurely short or burn out or damage the connected device. So shuttered sockets are great. One other thing you'll find with a shuttered socket is some of them have micro switches in the back which actually activate the rectifier in the rear of the unit, which obviously gives you the DC source. So these are a really good, efficient and safe design. However, under the British standard on the front cover, there is a requirement for the sockets to have the source of supply, the current and the voltage, which we've seen in other pictures, as you can see there, 2.1, 5 volt and the symbol for DC, We don't have it on this socket, henceforth this socket technically does not comply to BS 1363. Yet on the rear of said socket, it actually states, I don't know if you can see this, I really hope you can, but it actually states just on the back, BS 1363. So there you go. Excuse me. So a BS 1363 socket which doesn't fully comply, that may be manufacturer's choice, but under the letter of the law, doesn't comply. Although BS 1363 isn't a law, by the way, just to be clear. It's a code of practice, just like the wiring regulations are. Now, if I was an inspector, you see above me, C3, improvement recommendation, and hark, all the sparks go, what? No, you cannot code a socket outlet that doesn't have a scribble on it. Well, that's down to the inspector. If I was inspecting a fixed installation, I would actually issue a C3 against the socket not complying with the standard. Now, under BS 7671, you only code what is in the wiring regulations. The wiring regulations don't cover that. However, it's fairly evident as time moves on, there is going to be non-codable observations for final parts of the fixed installation, which a socket outlet is. So this is where electricians need to start learning more about the British standards around the wiring regulations, hence this video. That's the symbol for a USB port. Again, USB means universal serial bus, and you find it on computers, TV screens, etc., boxes of equipment. It just tells you there's a USB port, which is great. Now, USB connectors. You have lots and lots of different types, as you can see from above me. You've got type A, you've then got type B, which is a squarer type. You've got type C. Now, type C is really interesting because this one here is going to be the one that becomes the default in the next 5 to 10 years. This is the one that appears to have been agreed as everything will be type C, which means you're eventually going to see these phased out, which is a real nuisance for a homeowner who expects these to last a good 25-30 years. So it's worth being mindful of that. Again, this is more information for you. You have micro USB A, you have micro USB B, you have micro USB Superseed, which is used on a lot of 4K HDMI connections. And remember, USB was designed to transmit data between devices. The obvious benefit is we get the benefit of being able to transfer 5 volts and some power in watts across to a device, which is great for charging. Now look at that. Look how many devices we have now. We have boxes. I mean, I have a box under this desk and it has hundreds of leads, literally hundreds of leads. So, and we all keep them because we don't throw them away because you never know when they'll be handy. But that's the scenario we're in at the moment. So let's look at standards in a nutshell now. Quick whistle stop tour through the standards. Now, why are standards really important? Well, standards are really important because they're supposed to be factual, objective. They are the baseline for which we make engineering or informed decisions as an electrician, as an inspector, as an engineer, a manager, a specifier. This is where we go to, the standards. However, there is a hierarchy of legislation and order of what you should follow. These tend to sit at the bottom. However, just for information, the first standards you should be looking at is this: the plugs and sockets, etc. Safety Regulations of 1994, which is called a statutory instrument, number 1768. So if you're looking for laws online on Google, they're all free. Everything that you must legally comply with is free, which is always fascinating. They're called statutory instruments. They're effectively instruments of Parliament which are laid down in law. If you don't follow them, you'll be prosecuted under that. However, most electricians who may not be familiar with that will look straight away and go, the Electricity at Work Regulations, EAWR 1989, statutory instrument number 635. That's the one that we as installers and inspectors are made very much aware of, because obviously Regulation 5, equipment fit for use, Regulation 8, earthing, 4, safe system of work, and then you've got the isolation ones, and competence, Regulation 16. However, there's something called PURE, Provision and Use of Workplace Equipment, that sits under that. And one of the many pieces of legislation. It's a really interesting document because at the end I'll read something out about compliance with a certain regulation. Now remember, USB socket outlets are part of the fixed installation and covered by BS 7671. However, the installation is covered by the Electricity at Work Regulations, Plugs and Sockets Regulations, and the provision and use of workplace equipment. So if you're in a workplace and you have a desk with socket outlets on them, then there is a requirement for maintenance, inspection, etc. and compliant equipment provided by the employer to the employee. So there's lots and lots of legislation around that. Now, quick FYI, British Standard 1363, it came out in 1947. It was called Fuse Plugs and Shutter Socket Outlets, and that's what it looked like over there. And now it's BS 1363 2016 amended 2018, and it consists of 5 parts, which is 430 pages I've had to read. Now, if there's anything inside you need to know, it's in this video, trust me. So, BS 1363, as you can see right there, that's the standard we're covering, because that's the standard that is relevant to socket outlets with USBs within them. The other standards that you see to the left and right are plug tops, fuse spurs, adapters, conversion plugs. But we're going to be mainly covering that one there. So some other standards, BSEN 60950, Part 1-2016. There's an interesting piece of knowledge. As of December the 20th, 2020, these are no longer to be used to confirm compliance with the low voltage directive. Now, I could do another video on low voltage directive and EMC and compliance with EMC, but the low voltage directive effectively applies to anything that's sold around Europe that should meet particular BSEN standards. So effectively, if you have that on the back of your socket, which I believe I have on, so this is the socket that you can buy in Wix, and this is made to the BSEN 60950, and as of December the 20th it will no longer comply with the OV directive. Wonder why they're selling them cheap. So there you go, so it's worth knowing. Next standard, BSEN 62368 AV, Information and Communications Technology Equipment. Now that's actually the standard for the USB itself. One that electricians don't really need to know much of, but that's what the actual standard covers. And then obviously we have BS 5733, General Requirements for Electrical Accessory Specification, basic tests, basic functional safety testing in there. But more importantly, we also have another standard which does cover USB socket outlets, which is BSEN 61558-2-16, which is the transformer rectifier, which we do have in the back of 99% of all domestic sockets sold in the UK. So let's look very quickly at some last bits of BS 1363-2 that are really important to know. 1. EMC, electromagnetic compatibility. Why is that important? Well, very simply, if I plug my iPhone and my iPad in, the last thing I want is a USB charger from damaging it, and likewise I shouldn't have to be able to plug something into it and cause damage to that. Now, EMC is more complex than that simple term because it deals with radiated emissions, conducted emissions, and how electromagnetic devices interact within the environment. So there's quite a lot to it, but it's worthwhile asking the manufacturers, have they actually tested and got evidence of having tested by an independent laboratory for compliance to those standards. It'd be fascinating to see what you get back. Here's an interesting part of the standard, section 1.3.2. Now it states, overcurrent protection shall be provided on the primary side of the USB circuit. Okay, where overcurrent protection is not provided within the USB circuit itself, provision should be made for appropriate overcurrent protection in the supply to the USB circuit within the socket outlet. Okay, so that's interesting. So there must be overcurrent protection for the rectifier part of the circuit, evidently, so where it comes from mains, so that short part internally. But it then says the USB circuit shall not rely on the building or installation protective device. So if I'm putting these on a BS 60898 type B 32 amp circuit or a ring, we can't rely on that, so there's got to be something inside the device. Now, how many people check to see whether these devices have that? Because you'll see some have quite a thick profile, some have a very slim profile. So it's worth checking to see what these devices actually have as far as overcurrent protection internally. Now, look at the note. It says provision for overcurrent protection provided within the USB can be verified by reference to the original test report. Now, I have lots of these sockets, but I can't manage to get hold of the original test reports. Last one, 134.2. USB circuits intended for charging portable devices shall conform to the requirements for dedicated charging points. BSEN 62680-1 2015. So if I look here again at the one that I bought from Wix, it says 60950 5733, which is a very basic standard, and it doesn't mention that standard whatsoever. However, I am using it for charging portable devices. Interesting. You can see why they're cheap. So the last part of BS 1363-2 that is of relevance to the inspector or electrician and installer is in Annex I, which deals with the USB parts. Now, 3.1.1 is about power rating and identification markings, and it states the input voltage rating of the USB circuit shall not be marked on the socket outlet and shall not be less than the rated voltage of the socket outlet, which basically means I don't have to put 240 volt on the front, I don't really have to put it on the back. However, a lot of manufacturers will by default emboss it into the back of the devices. The more interesting part is it states marking of the USB circuit output. The following markings shall be visible after the socket outlet has been installed as in normal use. So that's when the electrician has finished, put his screw caps on, issued a minor works or an electrical installation certificate, which he should be doing, and it states very clearly that the markings visible should include the symbol for nature of supply, for DC only, which is that bit there, the rated current in milliamperes or amperes, 2.1 or 2100 milliamps, and the rated output voltage. Now, if I go back to this device, which is the Eaton one, it's actually pretty well built, but the Eaton one doesn't comply, and yet on the back it clearly states it's compliant with BS 1363. So I am as miffed as you watching this. But what it does tell us is different manufacturers have different ways of complying with the intent of the standards, or possibly they're not up to date with the current requirements of the standards. So it's worthwhile asking the question of your manufacturers or of your wholesalers and the people that provide you with the devices, just if anything to make sure you're future proof. As we saw, the device here on the left as of 2020 won't be compliant with the low voltage directive. So as the inspector, if I was going around and I found this device here, I would then give a C3 for improvement recommended. Why? Because it's out of scope of the wiring regulations, which I know I don't have to, but as a diligent inspector, as a competent inspector, these are issues which I may wish to highlight to my client. Now, as a client, I can tell you now, I would go, yeah, okay, I'm not too fussed. However, I would start looking into these, because we all just assume that these are fully compliant with the requirements of all the standards. So the next thing I did with USB socket outlets was look at the standard again and ask the question, should we be verifying them? Now let's go back to the bit at the start, Annex I, section 3.5, conformity. Conformity to 3.1 to 3.4 shall be checked by inspection of conformity evidence or by test. Are we getting conformity evidence from the manufacturers? No, we don't really get it. We get a statement that they conform, but we don't get evidence of it. And do we test it? Henceforth, how would we test it? So if we were to test it, then this standard particularly, what sort of test would we employ? So for me, I could do thermal imaging, I could look at voltage output, I could look at maximum demand, and I could do overload tests. But how would I actually do that? So let's have a look at a video. So this is me plugging in my iPad next to a Schneider Elise socket, and as you can see, I've got the two spots there just to give me a bit of a benchmark on temperature differential. The 23 degrees at the bottom that's glowing orange, this is obviously sped up, is where the rectifier in the back of the socket is getting hot. As you can see, the wire is getting warm from carrying the current. I've then plugged a second device in, and what you can see straight away from the faceplate is there's a 10 degrees difference and a 4 degrees difference at the point of delivery. So it's a fascinating view of how these devices perform under thermal stresses. Now thermal stresses are really important because they're an external influence, but a USB charger now introduces an external influence within the fixed body of a socket. So getting the quality right for a socket outlet with a USB is really important to the safety of the installation, in my opinion. And I'm sure if you have different opinions, you'll put them in the comments below. But again, it's a fascinating insight. So moving on from testing, I bought myself a new toy. And this is the toy, and I'll put the link in the description. And this is a USB meter. Now they're used all across the world in electronics manufacturing companies. So I decided to buy one, and it's a lot of fun. So what did I do? Well, I bought it with an electronic load resistor that you can see there, the LD25. And what that's got is a precision multi-turn adjustable potentiometer, which is the little blue corner here, and that you can just turn up with your finger, and you can select the resistance, and you can then deliver a load, a simulated load of however many milliamps or amps you want. As you can see from the device, there's ports for USB-C, there's lots of buttons, and it's an absolutely fantastic device. So of course, what did I do? I plugged it in, I had a play. So this is one of those Wick sockets. As you can see from the video, the output is 5.13 volts, 0.12 amps, and we're going to press play and see what we did. So as you can see, it's in. The load's flashing. I've pushed the on button there, and that states 2.19, and it's 2.16. A slight difference. It gives me the milliwatt hours and milliamp hours. It gives me the voltage across the positive and negative, temperature. It gives me a screen that shows the milliamp hours and milliwatt hours. It gives me also how long that I'm timing this for. I can push a button and go next again. The fan, by the way, is just a cooler for the heatsink. As you can see, it's telling me I've got a resistive load going through the unit. That part there is fascinating. We'll cover that in a second. But it also gives me an analog or view of the voltage and current. So if I were to turn the dial up and down, I can actually monitor the peaks and troughs. But more importantly, I get to see power quality output. And then you've got the options menu as well. This device here is Bluetooth enabled, which means you can plug it into your phone or your computer, and you can export graphs in Excel. So it's an absolutely amazing device, to be perfectly frank, because what I can do is I can literally spend 10 minutes pulling 2.1 amp hours. I can use my thermal imaging camera to see what the impact is. I can actually verify the output and the performance of a USB in situ in my customer's house. Why? Assurance, safety, quality. I can get all of that from spending a little bit of time verifying and validating the performance of these devices. Yes, I know a lot of people who've watched this video have gone, don't be silly, it's 5 volt, it's cell safety extra low voltage, there is no need to test it whatsoever. However, we know that there are devices out there which people charge, they go in, they use fake leads, fake chargers, and they cause danger, they cause fire, you get leads burning out, arcing. Anything of any electrical source of energy is a potential hazard. Just because it's below the perceptual touch voltage threshold doesn't mean it can't give rise to some form of danger or hazard. So let's go on to the next load, because obviously that's a USB socket outlet. So this next video is on my desk, as you can see, and what we're going to do is we're going to play around with the USB and introduce you to all the bits and the gadgets so that you can see it a bit clearer. Great for testing the performance of battery packs, more specifically for charging. Now, as you can see on that video, there's a USB 3.0 there. There's some buttons on and off. There's a USB-C, male USB, some more buttons for selecting options. That there is the Bluetooth switch for connecting to your phone, and then obviously a micro USB at the top. Now the Bluetooth switch, if it's off, will reduce less power, so you'll get a more accurate reading between the two. But while I was doing this, I had the USB switch, the Bluetooth switched on, so that was obviously that electronic circuit was using power. This device here, LD25, is a variable load bank. It's got a setting button so I can set it to come on at a specific current straight away if I want, and an off switch, and obviously you can plug in micro USBs and USB-Cs. So very simply, you plug the two together, and that gives you the setup you need to measure the load. Now this is just a cheap freebie one you get at trade shows. It's got an LED lamp in it and it just gives you a simple indicator of the charge. It's 2.1. Plug it in, you then get the data screen come up. 4.96 volt, 1.5 amp was the initial load up. As you can see there, 1.51 amp. So straight away I've plugged it in. That was the last setting I used, so that's why it's come up with it. If I turn the potentiometer, it goes up to 1.55, and as you can see, 1.55 is exactly what you get. Now the battery temperature is already at 28 degrees, so if I start turning that up slowly, 1.6 amps, 1.65, and what I'm trying to do is I'm trying to now overload the battery. Ice will go up, and obviously the fan then kicks in to cool it. I'm now at close to 2.1, which is the rating of the load of the battery. So there you go. So that is the rating of the battery. That's the maximum delivery charge. I'm now going to push it further. I want to see whether this device has any form of internal protection. So 2.2 amps, I'm still going. 2.3, so I'm going a bit above what the manufacturers have stated it's going at. 2.4 amps, so straight away I'm 0.3 of an amp above, and I'm now at 2.5 amps on a 2.1 output. 2.6, 2.7, so I'm wondering now if there's a protective device or not. 2.8, and of course it's tripped out. There we go. So the device itself has switched itself off to protect itself. Now I don't mean these devices, I mean the actual battery. So the output circuit has actually realised too much current's being pulled from a faulty connected product, and it's now shutting off to protect itself and the battery. So I'd say that's a pretty successful overload test there. Now obviously, why do I want to do an overload test? Now I wouldn't do it on every single one, but I would do it for my own verification to assure myself that the equipment I'm using is fit for purpose, that it has those safety features, because we buy this stuff off the shelf, and sometimes with the cheap electronics that some of the guys pull apart on YouTube, you never know. And I'm sure BigClive.com or JW are the ideal sites to go for electrical equipment being pulled apart. I won't be pulling this apart. So on to the next real issue with USB socket outlets, and that is lightning, overvoltage, transients, voltages that appear that shouldn't necessarily be there. Now in BS7671, the latest edition, there's a whole section on transients and overvoltage protection, and we seem to now in this edition have rolled out the surge protection devices. So let's get into surge protection devices. Now I'm not going to cover all of the criteria of surge protection devices, because Sparky Ninja's channel does that, and GSH, as well as many other YouTubers. However, there's a section in part I which I found really interesting. I can't get an answer from a manufacturer. The USB circuit shall be designed and constructed to the requirements of overvoltage category 3. Well, that's cracking, that's great, that's local protection. USB circuits of overvoltage category 2 can be used where additional overvoltage protection is required within the socket outlet, i.e. varistor or equivalent. Now I can tell you now, of all of the socket outlets I have, none of them tell me what the overvoltage protection category is, or give any indication of varistors or any other equivalent overvoltage protection. The note is the fascinating thing. USB circuits are generally tested to category 2, whereas sockets are overvoltage category 3. So what they're saying is in the latest BS 1363-2 standard, the USB component shall be tested to category 3, as will the actual body of the socket. So that's a step up in the standard, which is a great thing. Probably doesn't answer all the questions that you're wanting to write down there. So let's move on to surge protection devices in brief. So here's a great picture of a Hager board. This is a brand new 18th edition board which is being shown at Alex trade shows around the country. It's a cracking board because it has individual RCBOs, so we don't get any nuisance tripping of circuits that we don't want tripping out. It does have the fly leads on the neutrals, which is a bit of a shame, but you just plug your live and neutral into the top. Now with this board, something different is these parts here on the far right, which is the surge protection devices. You can see it here clearer. Crabtree have their own version, and Proteus and Chint and many other companies do. Now all this does is it takes a live and neutral from the bottom of the outgoing of the main switch into the top, and what that's supposed to do is any overvoltage or transients that would spike on that mains, it effectively would go through this device. This device would then safely discharge, recognise it and discharge via a 16mm CPC to the earth bar and away. That's what it's supposed to do. However, over time, as you can see from these green bars, that protection will wear away. So a surge protection device is something you then have to maintain. Similar, I suppose, to the push button, but it's something you have to look for. Now, in a domestic market, homeowners aren't necessarily doing that. So that's another risk. That's potentially another label, which isn't in BS 7671, we may want to put on the boards. So for you contractors out there, if you're installing 18th edition compliant boards, make sure you have a label that clearly states surge protection fitted and what the consumer has to look for when the surge protection comes to the end of its life or is damaged protecting the fixed installation. So, relevant stuff. How relevant to these? Well, section I again, 4.1 general. Surge protection devices incorporated into socket outlets shall conform to the requirements in 1.4.2. Again, more criteria. The note that comes with it is the worry. It states the use of SPDs, surge protection devices, variously known as voltage dependent resistors in old money, gas discharge tubes, avalanche breakdown diodes and similar devices, might have particular applications and restrictions in their use in many safety standards. I would assume there are lots of special locations where you may not want to use these sorts of devices. However, restrictions are applied where the disconnection of earth is possible as a single fault condition. For example, to domestic pluggable equipment, you may have equipment which runs IT plant which disconnects the earth as well in the event of a mains loss. I have seen UPSs where in the event of a mains outage they switch out the DNO earth and use a local earth electrode as a reference. Now, the slow deterioration of surge protections with time might result in an increased leakage current. Now, we all know electrical installations with modern electronics all leak to earth. The old TFT monitors used to leak 3.5 milliamps. You know, if the easiest way of checking is put a clamp meter, a very sensitive clamp meter on your main DNO earth, and you'll probably see that you get some small amount of current. On major installations, I've measured leakage current in the tens of amps before from connected power transformers, power electronics, lots of waste leakage in poorly constructed and inefficient equipment. So the slow deterioration of surge protection might increase leakage current. This causes a permanent and continuous increase in temperature stress, which can cause the component to burn or burst. Thus, surge protection devices are regarded as safety hazards. Now, it's fairly evident I have two standards that potentially are conflicting, and yet we as electricians are being told, go and fit surge protection devices, do the formulas, do the risk assessment, but when we do it, we end up being told you have to do it anyway. It's my kind of a pet hate I have about the lightning protection industry, because in the old days, BS 6651 gave you a really good formula for do I need to do lightning protection. Now the formulas are just basically do it. I've never been on an installation where the minute you do a lightning protection risk assessment, you don't have to buy a rod, a tape and a piece of equipment. So for me, on my domestic installation, I will be doing a risk assessment and a departure where I will document the fact that I don't want surge protection. However, this is the problem. Now, I know there are industry bodies who are working on guidance for this new technology, so I would hold fire until these trade associations are actually putting the advice out, giving you the support needed to correctly select and erect surge protection devices. This annex doesn't cover comprehensive type testing, which is specified in another series of standards, BSEN 61643. So electricians know within the annexes there is an annex that just covers standards. Now, over time, when a standard gets improved and the substandards gets improved, not everything makes it into the main body of the standard. Sometimes there are conflicts like this one. So what do we know? Well, we know BS 1363-2 2016 has been updated. So that's fine, we know that. We know the wiring regulations has been updated. but it still leaves the confusion with this question, which has been in the standard for a while. And it says conformity to 3.1 and 3.4 shall be checked by inspection of conformity evidence or by test. Henceforth, USB meter testing with simulated loads. If the manufacturers do it, great, but there's always the risk that the manufacturers don't do every single device. They will do batch testing. As a contractor wanting to maintain a reputation, I would suggest that you do test so that you can find and verify the manufacturers themselves, because some compliance, as we know, the one I got from Wix in 2020 will not be compliant to the LV directive. So should it be a coded observation? Also, the socket that doesn't have the markings on it, should it be a coded observation? Officially, no, because we code to 7671. However, the standards are referenced in 7671, and I would consider it as due diligence and also thinking in a bigger picture to protect your consumers, your customers, and your clients. Surge protection devices, well, they're possibly regarded as safety hazards, as we've just seen. How much? You need to go to the surge protection experts, and the surge protection experts will probably say the exact opposite of what I've told you. However, surge protection shouldn't be a science. It should be very, very simple to understand. There is currently nothing out there that explains it in the layman's terms. As it stands, I'm happy to take the risk. But more importantly, the one thing that I am seeing in surge protection is we seem to be within fixed electrical installations. And yeah, this is a rant. Okay, so within the 18th edition, we've introduced arc fault detection, we've introduced surge protection. Are we mitigating for poor white goods? Because it would appear we are. And also, are we mitigating for failures within the supply network falling apart due to its age and lack of investment by private companies? Either way, it appears, I'm not saying it is, but it appears that the wiring regulations are being used by manufacturers to effectively mitigate the failures of private enterprises to maintain quality in their networks and the products they're producing. I'll let you be the judge. Democracy is a wonderful thing. But what can we do about it? Well, we can do lots and lots of things. You can go and get a thermal imaging camera, which I highly recommend all electricians get because they're fantastic toys, especially the Flow 1 Pro that plugs into your iPhones. But we can also test to verify the voltage quality and the output. We can do that because the output of the rectifier, it should be constant, it should be well maintained, because obviously we don't want the voltage going up and down when we're charging our phones, because that can have adverse effects on the battery, and it means we've got a really cheap component inside. So verify the quality of the output of the rectifier. We can then look at maximum demand, and then also in that we can look at overload protection, as you've seen in the video. We can advise our customers on what they need to know and how to work safely around USBs, and advise them when selecting the right products, whether or not in their houses, if they've got small children, they'll want the shutter types. We can also verify quality of manufacturers. More and more components, more and more guys on social media are complaining about quality. BigClive.com, JW, phenomenal people, just tearing the backside out of some of the equipment that is sold on eBay and on Amazon. So we have to be more cautious, because trading standards, they only look at 1% of 1% of 1% of 1% of stuff coming into the country, and it's normally always when somebody has been hurt. So as a contractor, I think we're duty bound to check and inspect and conform evidence or test the output of these new power electronic devices. Load banks, voltage testers. Well, there's an added benefit of buying one of them, and I think you should all have them in your kit. They can actually prove the lead resistance and continuity. So if you're called back because your socket outlet you fitted is broken and it don't work, and they're having a go at you, all you've got to do is say, where's your iPhone lead? Plug the iPhone lead in, and if it's a broken lead because it's cheap rubbish, you can actually prove that your part of the job has been done well and the products you've chosen are quality, but more importantly, you can give them a bill for wasting your time. So where does this then lead us? Well, I'm hoping in the next edition of the wiring regulations, if that is the colour, in the next edition it would be really good to see these gaps being plugged, as well as obviously all the typos, the spelling mistakes, the label size errors, and all the other dozens of incorrect references which didn't make it into the core addendum and are still in the book that we're paying a lot of money for, so please fix it. It would be great to see some more information on the use of electronics. Now, I know the people who sit on these committees will probably say, no, it's pluggable, it's fixed, it's pluggable equipment, it's portable, we're not responsible for that. However, there is a requirement for you guys to do your duty of care and inform the contractor selected on erecting the installation and ensure there are no gaps. The 18th edition was full of gaps, full of errors. We've got to fix it, and we've got to stand up and admit that it was full of errors and wrong and get it fixed. So what's next? Well, the workplace. We're using sockets in the workplace. Let's go away from the domestic dweller. This socket is in a workplace. Well, I know it is because I've actually got some of these in my workplace. And is it work equipment? Well, it kind of is, because it's equipment that's provided for me to plug in my phone chargers or whatever other devices. So it would be covered by something called PURE, as we mentioned earlier, Regulation 10. So let's get into PURE, Provision and Use of Workplace Equipment Regulations. Now, in PURE, Regulation 10 states every employer shall ensure, there's the shall word, that an item of work equipment conforms at all times with any essential requirements. In this regulation, essential requirements in relation to an item of work equipment means requirements relating to the design and construction of work equipment of its type in any of the instruments listed in Schedule 1, instruments being statutory instruments, etc., etc. But also give effect to community directives concerning safety of products. Henceforth, the line earlier on where we mentioned about this will no longer comply with the LV directive as of 2020. As of 2020, if I installed this socket which I bought from Wix, in theory or in practice, this is no longer compliant with the provision and use of workplace equipment if it's in a workplace. What this tells you straight away is the people who sit on the British Standards Committees may not be attached to the fact that the legislation is the stuff that we're going to get prosecuted on and not following of a code of practice. So there is a bit of a misgap there. I may do a video on just hierarchy of health and safety legislation to help you in the next coming months, because it is a minefield and everybody seems to think that the wiring regulations and British standards are absolute statutories, and they're absolutely not. They're absolutely not. They're a code of practice. Section 3. This regulation applies to items of work equipment provided for use in the premises or undertaking of the employer for the first time after 1992. Regulation 10 is about conforming to conformity rules. By community rules, that's the EU community, i.e. the LV directive. The rules are covered by a number of existing regulations and are now included within PURE. So regulation is about the rules that make the equipment safe as it is designed, manufactured and provided for use. The regulation specifies the need to comply with the existing regulation and therefore the community requirements for equipment of a certain age. So effectively after 1992, if the manufacturers change the specifications or the standards, more importantly, and it doesn't comply with a community rule, i.e. the LV directive, then you're in breach of PURE. So I told you there would be a few really insightful things to think about on what is effectively a subject matter we all take for granted on a daily basis. But that's what happens when you introduce new technology into an old system. Sometimes it may not all work as well as we want. So that's it, really. Just remember, 3.5, conformity. It shall be checked by inspection of conformity evidence or by test. So that's it, folks. That's the end of my first video. Hopefully I've not bored you for too long. Hopefully I've given you some unique insights and things to think about, some new toys to go out and buy. But more importantly, if you want to know anything more about sockets and the hazards around socket outlets, I suggest you really go and check out Fatally Flawed, which is a great campaign which deals with the childproof socket inserts, which is a socially responsible campaign which is close to our heart. But more importantly, the one thing I want you to take away from this is the E5 group as an entity of people working together as a cooperative. We really do want to influence, to inspire, to inform you with unique information, and by doing that we want to support and we want to educate you. So until next time, and whichever random video topic we choose, which will, for me, it'll probably be client stuff or code breaker stuff, or stay tuned. Thank you very much for watching our channel, and we'll see you again. And in the meantime, I want you to check out all the people that appear on this bit of the video for the last 5 seconds, because they're great channels, great people. Thanks for watching. Take care.